This question is about understanding Gaussian mixture models, a statistical model used to represent data as a mixture of several Gaussian distributions. It's like saying, instead of one bell curve, your data might actually be a combination of several overlapping bell curves. We'll focus on how Sklearn, a popular Python machine learning library, handles these models. We're using Sklearn's ''GaussianMixture'' function to model data. The ''n_ components equals 3 part means I'm assuming my data is generated from a mix of 3 different Gaussian distributions, each with its own shape and position. Think of it as 3 different bell curves all mixed together. After fitting the model, the ''means_" attribute gives me a 3x2 array. This tells me something important about the structure of the data. The 3 refers to the 3 Gaussian distributions, as specified by ''n_ components", and the 2 means each data point has 2 features or characteristics. For example, if you are modeling heights and weights, then each data point has 2 features, height and weight. This explains the 2. This statement is correct. Each row in that 3x2 array represents the average values, mean, for a single Gaussian component. So, the first row gives you the average values for the first Gaussian distribution, the second row for the second distribution, and so on. This is also correct. The number of columns, 2 in this case, tells me how many dimensions or features my data has. It's like finding the number of axes on your data's graph. Absolutely. The ''means_" attribute only gets populated once I've actually trained the model on my data using the ''fit" method. Before fitting the model, the means are not calculated, so this is necessary. I see, fit. In Sklearn's Gaussian mixture, the method trains the model on your data. Before you call, the model is untrained. It doesn't know anything about the data's characteristics yet. After calling, the model learns the parameters that best describe the data, like the means and covariances of each Gaussian component. This is the attribute that stores the calculated mean vectors of each Gaussian component. I use it to access those means. These means are only available after the model has been fit to the data. If you try to access it before fitting the data, you'll get an error. This is a type of model that assumes your data comes from a mixture of several Gaussian distributions, like a combination of bell curves, each with its own mean, standard deviation, or more generally, covariance, and proportion in the mixture. Gaussian mixture, part of Sklearn, helps you learn these parameters from your data. I see a 3x2 array. This means 3 rows and 2 columns. Each row represents the average values, the mean vector, for one of the 3 groups of data points that the Gaussian mixture model, GMM, identified. The 2 columns show that each data point has 2 characteristics, 2 dimensions. Think of it like this: you're measuring the height and weight of people. So each person has 2 measurements, height and weight. If you split the people into 3 groups based on similar height and weight, then each group has its own average height and weight, which form a row in the ''means_" array. Got it? This directly explains the meaning of each row in the 3x2 ''means_" array that I described before. Each row gives you the average values of the 2 characteristics for one of the 3 groups. This ties directly to the 3, 2 shape. The 3 is the number of groups and the 2 is the number of characteristics measured for each data point within those groups. This explains what the 2 columns in the 3x2 array represent. The 2 columns show the 2 dimensions or characteristics of the data points. It tells us that each data point I'm working with has 2 pieces of information connected to it. Imagine 2 columns, height and weight. Each row would then give the average height and weight for one of the 3 groups. I see this refers to the core concept, a Gaussian mixture model, GMM, which is a probabilistic model that assumes your data is generated from a mixture of several Gaussian distributions. The ''means_" attribute is a crucial part of this model. It stores the calculated mean vectors for each of these Gaussian distributions after you fit the model to your data. In simpler terms, imagine you have a handful of marbles of different sizes, colors and shapes. GMM tries to figure out which size group, color group and shape group the marbles fall into. The means _ attribute then tells you the average size, color, and shape for each group. Pretty cool, huh? This section lays out the core problem. You've used scikit-learn's GaussianMixture to fit a model, and now you must interpret the means _ attributes meaning and shape. This is a typical machine learning scenario where understanding model outputs is key. This is a crucial part of the problem. The shape, 3, 2, tells us that we have 3 separate mean vectors, each with 2 values. This implies that each Gaussian distribution in the model describes data with 2 features or dimensions. For instance, it could be height and weight, or maybe temperature and pressure. So, each row represents a group's average height and weight, or average temperature and pressure. Fitting the model using the fit method is the essential step here. Before you can access means _ the model needs to be trained on some data using the fit method. Think of it like teaching a dog a new trick. You have to train it first, fitting, before you can expect it to perform. Access attributes like means _. Here, you're specifying that you're using a Gaussian mixture model that assumes your data comes from 3 distinct Gaussian distributions, groups or clusters. The n_ components equals 3 parameter sets this. So the GMM tries to split the data into these 3 groups. Each group is characterized by its own mean and covariance. This step is implied. You need input data to train the GMM model. The data is what the GMM model learns from and then generates the means _ attribute from the groups that it has created. It is the information that is used to calculate the means. Let's break down this question about the means _ attribute. We're using scikit-learn's Gaussian mixture to model data, assuming it comes from 3 different Gaussian distributions. The core of the question is understanding what the means _ attribute tells us after fitting this model. I'm using the GaussianMixture function in the scikit-learn library. It's a powerful tool for modeling data that might be generated from a mixture of different Gaussian distributions. I've set n_ components equals 3 telling the function to look for 3 such distributions within the data. After fitting the model to data, I can access the means _ attribute, a NumPy array with a shape of 3, 2. The question is, what does that shape, 3, 2, represent about the model and the underlying data? That's absolutely correct. The 2 in 3, 2 tells me the data has 2 dimensions or features. Think of it like this: if you're measuring height and weight, you'd have 2 dimensions. Yes, this is true. The MEANS attribute only gets populated after I've used the _fit method of my GaussianMixture object. This is because is what actually trains my model and gets the parameter values, including the means, of each of the Gaussian components. The shape, 3, 2, is crucial here. The 3 represents the 3 Gaussian components I assumed exist in the data. Each row in the means _ array represents the mean of one of those 3 components. The 2 represents the 2 dimensions of each data point. Let's emphasize those key numbers in the shape, 3, 2. The 3 means 3 separate Gaussian distributions that make up the overall model, and the 2 means the data points have 2 different features that were used to create the model. I'm asking you to interpret the means _ attribute returned by scikit-learn's Gaussian mixture model. We'll focus on understanding what the shape and values of this attribute tell us about the model and the data. This is crucial for interpreting the results of your model fitting. Think about what means _ represents in a Gaussian mixture model, GMM, context. This statement is incorrect. The covariance matrices are stored separately in the covariances _ attribute of the Gaussian mixture object, not in means _ means _ focuses only on the average values or centers of the Gaussian distributions. Remember the difference between mean and covariance. This is correct. The number of columns in the backquote means underscore backquote array, which is 2 in this case, tells us that each data point in my dataset has 2 features or dimensions. For example, my data could represent height and weight, or latitude and longitude. It reflects the structure of the data itself, not just the model. Absolutely correct. The backquote means underscore backquote attribute is computed only asterisk after you train the GaussianMixture model on your data using the backquote fit, backquote method. Before fitting, the backquote means underscore backquote attribute would be undefined. It's the result of the model learning from the data. That's right. Each row in the backquote means underscore backquote array represents the mean vector for one of the 3 Gaussian components. This vector defines the center or average of that specific Gaussian distribution. Since we have 3 components, there are 3 mean vectors. Yes. The number of columns in backquote means underscore backquote equals the number of features in my original data. In this case, 2 columns indicate that my data points are described by 2 features each. For instance, it could mean 2 features like size and weight, length and width, or any other pair of measurable qualities. This question tests your understanding of the GaussianMixture model in Sklearn. I'm asking you to interpret the output of the backquote means underscore backquote attribute after fitting a Gaussian mixture model, GMM. A GMM assumes that data comes from a mixture of Gaussian distributions, each with its own mean and covariance. Think about what backquote means underscore backquote tells you about these distributions. Correct. The number of columns in the backquote means underscore backquote array tells you the number of features, or dimensions, in your original dataset. If you had a dataset with information on height and weight, for example, the number of columns would be 2 because there are 2 features. That's what this answer is highlighting. The shape of the backquote means underscore backquote attribute tells us a lot. Backquote, 3, 2, backquote means we have 3 rows, and each row represents the mean of one of 3 different Gaussian distributions. The 2 columns represent the 2 dimensions of our data. It's like a neat little summary of the central tendencies in our model. Absolutely. The backquote means underscore backquote attribute isn't magically there. It only gets populated after you use the backquote fit backquote method to train the GaussianMixture model on your data. Before training, it's essentially empty. So, remember to train your model first to get this attribute. Nope. That information is stored in the backquote covariances underscore backquote attribute, not backquote means underscore backquote. The backquote means underscore backquote attribute specifically stores the means. Think of them as the centers of each Gaussian distribution. The GaussianMixture model, GMM, is a probabilistic model that assumes that your data is generated from a mixture of multiple Gaussian distributions. Each distribution has its own mean vector and covariance matrix. The GMM aims to find the parameters, means, covariances, of these distributions that best fit your data. Think of it like fitting a jigsaw puzzle. You're trying to find the pieces that best represent the whole picture. This is a key part of understanding the output. Each row in the backquote means underscore backquote array represents a mean vector. A mean for each Gaussian distribution in your model. Each distribution has its own center or mean. Sklearn is a popular Python library for machine learning. It provides a convenient implementation of the GaussianMixture model, GaussianMixture, making it easy to work with. That's the tool we're using to tackle this problem. I already explained this earlier, but it's worth re-emphasizing. GMM is a model that assumes your data is a mixture of Gaussian distributions. It's a powerful tool for clustering or density estimation. I've already explained this above. Remember, each row represents the mean, center, for one of your Gaussian distributions.